Ladies and gentlemen, welcome back to the Mikey Pipes by ACiQ 4-ton heat pump installation. Today we're going to finish up this installation by installing the air handler in the attic with a high-rise emergency drain pan, new line set, the ACiQ communicating thermostat, and the control wire. We're going to replace the disconnect, run a new electrical line, and hopefully document step-by-step the entire process. Hopefully is the key word. But nonetheless, at the end of the video, let me get your thoughts and feedback down in the comment section down below. And as always, please subscribe. It's the best way of supporting the channel and my business. Hit that thumbs up button and hit that notification bell to get post notifications when I drop a video. Are you guys ready? Let's go! What's going on, ladies and gentlemen? Thank you so much for tuning in. It's me, Mikey Pipes. Monday, September 22nd, 2025. It is the day before the Jewish New Year of Rosh Hashanah. We have a very special project this morning that we need to complete before the holiday. We're putting in a 4-ton Mikey Pipes by ACiQ side-discharge heat pump inverter. This is a fully communicating system, advanced technology for better airflow distribution, temperature and humidity control, as well as offering heating and cooling from the same equipment. The outdoor unit is a beautiful, sleek, side-discharge outdoor heat pump condenser. Not your typical system that you see, and kind of resembles a ductless mini split, but this bad boy is 48,000 BTUs. See that? See what just happened there? Wow. All right, I'm right around the corner from the job site. Hopefully I can record the majority of the install. Now, we already previously mounted the outdoor unit, so we have to run the line set, install the indoor air handler, and we'll be good to go. The objective is to be done before 1 o'clock. Let's go. All right, almost 20 after 8 here in the morning. I started the recovery process and found that there was tons and tons of dye in the system. I guess they kept shooting. Sealant into the system, and there's probably some kind of restriction in the system as well here. But the condensing unit is disconnected. I was working on the disconnect when the recovery machine was done, so I got rid of that, and look how they got the line height cover. They didn't even split it. And there's an older line set there, evident by that inch and a quarter. Sorry, inch and an eighth. Sorry. There as well. So let's finish the disconnect. All right, folks. It's 10 o'clock. They say a job is not a job unless you're bleeding. Well, I'm bleeding, folks. And now I'm using the 3/8 soft copper pipe straightener on this 3/8 line that I have going upstairs to the attic, and as now you can say she's straight. All right, I have 3/4 soft tubing going into the attic about 5 feet. We, as you saw, in the uncensored video on the uncensored channel, we were a little short on 3/4 and 3/8 by 50-foot line set in the shop. I thought we had an extra roll, but we don't. So we're going to piece together 2 line sets with the ZoomLock and make up the difference. Yeah, we're dead level there. You know, the eyes play tricks on you, you know, but this is starting to look really, really nice. Since I last recorded, I got the square D disconnect box there. It's got that, looks like a circuit breaker, but there's no load protection there. It's just a regular switch, double pole switch, single throw. I ran 1/2-inch Liquidite, and I put in a couple 1/2-inch PVC clamps or straps to secure that Liquidite to the side of the home. Wired in L1, L2, and ground. And I'm gonna hook up the 3/8, and then I'm gonna help them up in the attic. Well, at least that's the plan. So let me put a little bend there, and flare that, and then run my communication wire. All right, ladies and gentlemen, it is 20 minutes after 10 here. Still Monday, the 22nd of September. We have the helicopter homeowner behind us, but the line hide is complete. Hooked up the 3/4, the 3/8 with the NAVAC flaring tool. Hopefully we got no leaks there, but the flares did come out perfect. Line voltage, L1, L2 ground. Communicating. You can do either communicating with, they say non-polarity, S1, S2, or your traditional wiring, RC, 24 volt common, Y1, Y2, and then your heat pump, OB. But we love to do the 2-wire from the indoor to the outdoor, only because we can install this in any situation, because we always have common and Y going outside regardless, but we always generally replace the wiring. So S1 is red, S2 is white. There's nothing else to do out here except put the cover on and help them with the line set up in the attic. And we are still level. All right, ladies and gentlemen, it's 20 after 11. My sincerest apologies for not documenting on video that much of this installation. I'm really in a time crunch here. I don't want to rush through the job, but I also have to get this job done much earlier than we normally get jobs done, only because it's the day, hours before the holiday starts. And not only does this family need to prepare, but I need to get home and prepare, help the wife and help the in-laws and help everyone that's at my house right now. So my apologies. We have the unit powered up on the inside unit. We have, my battery keeps dying on my JB Climate Class Smart Probe. We're at 135.1. We're pressurized with the expansion valve open on our 3/4 and our 3/8. 135.2. It's dead again. We're gonna have to change the batteries in there. Not too shabby. The line set obviously is connected. The air handler is connected with power. The supply and return plumbs are connected, and I'll show you that in a minute. But I just wanted to show you this process right now. We are pressurizing with some nitrogen, just checking for leaks. And then I'm gonna get the vacuum pump. We're gonna vacuum down. I have the Appion hoses here, the vacuum hoses with the yellow jacket. Yellow jacket? No, I'm sorry. The field piece. Cool little straight core removal tool. But let me change some batteries in there and get this thing vacuumed down. All right, let's dump the nitrogen. Let's hook up the micron gauge and start vacuuming down. The Blue Vac Plus, the micro. I like it. especially when it's new. It's even better. But they're true blue hoses. Not a fan. Not a fan. All right, almost 11:30. Tight. Ballast. Open. Let's vacuum down. Open. Tight. Open. I got no problem drinking. 19,000, 18, 17. 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, slowing down. 3. All right, let's revisit this in a little bit. We're at 3,000, 2,000, 2,800, 2,700, 2,600, 11:30 on the dot. All right, that line set, we ran all the way from that corner there, across, we came up, creating that trap, and beelined it right into the air handler. Beautiful, beautiful, sexy air handler. Daniel measured last week for a return plenum to connect to the new 18-inch flex. The transition piece over there. Condensate's already done. Emergency drain. This float switch. Very, very nice. And it's got that nice, sleek, rounded corners. Really makes this air handler, the Mikey Pipes by ACiQ, the Extreme Plus, fully communicating system. We're going to throw in that thermostat. Looks just like an Ecobee, and we are golden. All right, full disclosure. It's 11:35, folks. We're at 214 microns. 18, 1900, 2000, 21, 2080. 2080, we're solid. We're gonna keep pumping down though. We're stopping at 2080. That's awesome. Let's open up those valves back up. Keep pumping down. How low are we gonna get this to go? We're in no rush right now, folks. It's 11:36. We've been vacuuming down for 7 minutes. 200 microns. Ooh, she's struggling. She's struggling to get under 200. 201, 200, 199. There we go. You're gonna maintain. There you go. 198, 195, 194, 3, 2, 1. Yeah, that's a really tight and dry system. We're gonna let this run for another 10 more minutes, maybe 15 minutes or so. There's no rush. The objective is to be done by 12, and we're gonna be right on it. I think the keys will be in the ignition by 12. All right, folks. 1, 2, 3. It's 11:42. Now, some of you are going to be commenting on that 2-inch galvanized pipe with that rusted cap on top. That is the home's home heating oil vent line. Okay, that is the vent line, and this right there is called the alarm. That's the fill valve, the fill line. Now, some of you think you're armchair warriors and know everything. Some of you think that the AC unit that we installed above it by about 8 inches is a no-no. However, NFPA 31 clearly states the code involving this, right? NFPA 31, section 83, 87, specifically 8.7. 8.7.5, so 8.7.5 clearly states that all vent pipes shall terminate outside of buildings at the point no less than 2 feet measured vertically or horizontally from any building opening. That's really not a building opening. There's no other building openings here. And the outer end of the vent pipe shall terminate in a weatherproof vent cap or fitting, or shall be provided with a waterproof hood. Vent caps shall have a minimum free open area to the cross-sectional area of vent pipe and shall not employ screens finer than number 4 mesh. Right? So the vent caps, section 8.7.7, vent caps shall have a minimum free open area equal to the cross-sectional area of vent pipe and shall not employ screens finer than number 4 mesh. We'll take it the next step further. 8.7.8, vent pipes from tanks containing heaters shall extend to a location where oil vapors discharging from the vent will be readily diffused. Well, there's no heater in this tank. The tank is a 275-gallon tank inside in the home's basement. And the vent outlet of a supply tank shall terminate at least 5 feet, 1.5 meters, from any air inlet or any flue gas outlet of any appliance. Ladies and gentlemen, we are 100% to code here. We are good to go. If anything, this gives more protection to that vent. And ladies and gentlemen, so we're crystal clear, that's the vent, that's the fill. Let's see what our micron is at right now. 110, folks. Let's close that one. Let's close that one. Oh, come on, stop, baby. Come on. 671, 670, and we're dropping. Look at that, folks. And we're dropping. Beautiful. That is a very tight system. Let's keep going because it's only 11:46. I'm in no rush, folks. I'm in no rush. All right, while we're killing time and bringing even deeper vacuum here, let's talk a little bit about the operational specifications of the outdoor unit. We will provide heating at 100% capacity with an outdoor ambient temperature of 5 degrees Fahrenheit. And it will continue to heat, gradually going down to 0, unfortunately, right? To negative 22. So at negative 22 degrees Fahrenheit of outdoor ambient temperature. We're not talking about wind chill, we're talking about ambient temperature. This unit will still provide space heating to the indoor conditioned air. Epic. Now, that's one extreme. Now, we're on Long Island in New York. We don't see those kind of temperatures, but our cooling, outdoor temperature in the summer, 122 degrees, this thing will still provide cooling. Amazing. Oh, it went up. 101. 101. Can we get to 100? Can we get to 100 is the question. There we go, 100. It's struggling. It's like Bitcoin trying to go to 125,000. Come on, baby. Let's see 99. Let's see that 99. Come on, 99. All right. I'm getting tired of waiting. Let's isolate. Come on, slow down. Keep going. There you go. Dropping. Perfect. We are good to go. We went to a little over 500. Now we're dropping below. We are good to dump discharge. Back out a little bit. Now, these things are not that cooperative. They never are. Come on. One complaint. These things do not like to come out easy. Come on. Come on, let's go. Come on. There you go. Beautiful. You hear that? You can actually see that. Just keeping it real, folks. Keeping it real. Unbelievable. We did a pressure test. We vacuumed down the system. It dropped below 500 microns. Yet that flare connection is leaking. Huh. Unbelievable. See, I'm keeping it real. It's not all hunky-dory. Once in a while, there's an F up, and I can't explain this, but hopefully I can tighten it up and get that to stop. But wow, that's crazy. Not that I'm expecting the worst case scenario here, but it's still going. It's still leaking. Now that really does suck. I showed them the little bubbling action going on there. All right, so we're in negative pressure. You know what? There's nothing wrong with that flare. Or is there? Oh, a little piece of... Nah, really?
That was right where the bubble was.
Oh, man.
Yeah.
So we closed this valve. We hooked up our climate class probes to check for pressure. And then with the unit running in cooling mode, once it got to 0 and started dropping into negative pressure, we closed that and we sucked into vacuum. Let me cut this out and reflare it. 12:31. You see that stuff over there? That's for the PV system, the solar system that's generating power on the customer's roof. We want to take a wild guess what the Mikey Pipes by ACiQ 4-ton outdoor unit and the indoor blower running at right now. You want to take a guess? We're running at 100%, by the way. Can you hear that? No, you can't. Running at 100%. What do you think we're running right now? And you can guess in either kilowatt hour or amperage. Take a wild guess, folks. Take a wild guess. All right, ladies and gentlemen, job is complete. It is 2:28 here. I am home in my office, and I just wanted to show you some numbers that I got from the homeowner's solar system that he has on the roof. Now I'm gonna show you some data. It doesn't specify or it doesn't show where he lives, whatever. I'm trying to protect his privacy, but I'm gonna show you a picture right now, and this is with the system running. So here's his solar system. He's generating 6.7 kilowatts. His home is using 4 kilowatts, and that is with the system running. And he's charging the solar system that he has, the solar power wall that he has, the 3 batteries that he has, with 2.7 kilowatts. All right, so the entire home is using 4.0 kilowatts of power right now with the system running, the Mikey Pipes by ACiQ, the 4-ton system we just installed. Right, watch this. With the system off, 1.8. So we're essentially using 2 kilowatts of power. Interesting, huh? 2 kilowatts of power. My math isn't 100%, but I think that's around 7 amps of power for a 4-ton system. Not just the outdoor unit, but the indoor blower. That's incredible. His previous 4-ton system, that carrier system, it used 4.5 kilowatts of power total. Now, I don't have any data to prove that, to show you, but this is what the homeowner is telling me, and he is immediately seeing a 50% reduction in his home's electric usage for the HVAC system. That's epic. Now, what's more epic here is that he has oil heat. So you know what that means. In the winter, that banked money that he's saving, he's going to be close to net zero for heating and cooling in his home. And that, ladies and gentlemen, is epic. If you live in the Long Island, New York metropolitan area, and you're tired of getting bamboozled by your electric provider for running antiquated AC equipment, getting shafted by your oil company, pick up the phone and call me, 516-348-6300. And I would love to help you install an ultra-efficient communicating. And what that means is that the thermostat knows exactly what the components are doing. So when a blower dies, God forbid, it's going to shut the system down and tell you. On a traditional system, it'll keep running until the compressor dies too. And I got plenty of customers that have had that happen to. Thank you so much for watching, ladies and gentlemen. Really appreciate it. The feedback. Thank you. Be well. God bless. Stay safe.